My name is Dror, I'm from the OpenGSN team, and this video is an introduction to the gas station network, or GSN. In this tutorial I will show what GSN is, what is it good for, and what it takes to add it to your Ethereum project. Simply put, GSN is a mechanism that lets end users use dApps without having ETH to pay for the gas. You may think of it as a 9800 service where the caller doesn't have to pay for the call, it's the service provider that pays for it. Here are some use cases we see for GSN. One of the most important use cases is onboarding new users. How to let new users to work with the service without having first any crypto money to pay for the gas. Another use case is allow users that do have tokens to pay gas fees directly with those tokens without having to hold any ETH or converting this token to ETH. Yet another possibility is to pay for the gas directly with dollars or other fiat money. We are sure there are other exciting scenarios that we didn't think of. Let's look at the architecture of GSN. While it might look complex, most of it is completely hidden from the application and contract developers. At the top we can see the client application with attempt to make a call to the contract through some Web3 provider. With GSN, that provider redirects the call through one of the relayers in the network to the relay hub, which is the center of our system. The relay hub gets the paymaster approval before making the transaction through the system, and afterwards it collects the actual fees from it to reimburse the relay server for his effort. All this is done, of course, without sacrificing security or decentralization of the network. Okay, let's see the changes we need to make to our code to support GSN. There's a minimal change we need to make to our contract, and that everywhere we try to check the address of the calling user, we need to replace MSG sender, the calling address, with a helper function named MSG sender, which sees the real caller even though it came through the relay system as a meta transaction. And in the web application we need to wrap the injected Web3 provider with a GSN relay provider and provide it with the paymaster address that is willing to pay the gas for our transactions. Okay, let's move to the code. We created a sample project for this workshop. If you clone this project, it's a sample application that does use GSN, and I will follow all the requirements to add GSN to it. And if you want to shortcut through and see all the results, you have pull request that does everything I do in this video. So let's start by cloning the code. And install the dependencies. Okay. Okay, let's start Ganache. We have a helper script to start Ganache with deterministic addresses and the specific chain ID. And we can start a project. It will compile it, deploy it. Let's look at the code we have. This is a contract. We can see a single method, capture the flag. What it does, very simple. It saves the latest sender of the request and emit a message with its address and the previous address. We see now the contract is deployed. We can start the UI. When we click capture the flag, okay. It of course needs gas, so we can see the output, but it's Ganache. And with Ganache, we can specify 0 gas price, so we can at least see the output, and we see that the transaction is mined, and we see the event that says my address. We can see this is my address indeed capture the flag. Okay, let's add GSN to this application. First of all, from command line, first of all, we need to add the GSN contracts. For the JavaScript application, we need to add the GSN provider, and we need the utilities to start GSN. We'll see shortly. Okay, we added our dependencies. Now let's start GSN itself. We need to deploy a contract and start a relayer. So all we do is npx GSN start. This is the tool we added with the CLI, and it started GSN on our local Ganache. Okay, when we start GSN this way, it will create in the build folder a set of JSON files which contain all the addresses of the contract it deployed. We will see shortly when we use them. It deployed a paymaster. This is a test paymaster. It accepts everything for testing purposes, and we will use that. We don't need to copy the address. We'll use it directly from the code. Okay, first of all, the contract. The contract needs to be a GSN relay recipient. So let's import it. Okay, now we need some boilerplate code to connect it to the GSN network. We added a constructor that accepts a forwarder, and we added a version. We tell it that it is indeed the 220 protocol version. And of course, we need to use it. Everywhere we use the message sender, we use the helper method called msgsender. That works even when the call comes through GSN. Technically, the call comes from a forwarder, but it will let us know the real sender of the request, which will be our browser. That's the contract. Now we need to deploy it. We need a forwarder, so let's get a forwarder address. We read it from the build GSN forwarder and pass it as constructor parameter. Now we can deploy it. Lastly, we need, of course, to update the UI. Let's open our UI. First of all, I need a provider. We call it relay provider. Secondly, I will need the address of the paymaster that we deployed. Okay, now we need to replace the provider in the code. This is the Ethereum provider. We need to wrap. So first we pass it the current provider, and then we pass it a minimal configuration, which is the paymaster address. And let's not forget, we need to call init at the end. And of course, we need to use it. This is the change we need to our application. So now before we start, we need to make sure that Truffle will not get confused and remove the deployed contract. Okay, now when we start, it will recompile the contracts. It will run the migration to install the contract with the reference to the forwarder. The forwarder is already installed. And it will compile the UI. And we can go to our application. Now when we click capture the flag, we see the GSN request. We'll sign the request, and we will see the request came from my account. This is the address the contract received, and of course it didn't pay for any gas. So okay, so with this we conclude the first step of the GSN integration. Everything I did here is actually the pull request adding GSN support. You can follow all the changes here, changes to the contract, changes to the migration and everything. Okay. Let's move to the next phase, and that we want to add a custom paymaster, because with the current test what we actually did was using the default accept everything paymaster. We want to see what it takes to use our own specific paymaster. For this purpose, we created a project with some helper paymasters. We will add it to the project. We will use a paymaster we called whitelist paymaster. A whitelist paymaster allows us to specify specific addresses we trust to use, or contracts we trust to use with a project. So first of all, we need to add it to a project. We need to reference these contracts. So what I will do, I'll create an import file. All this import, it is Solidity file just to import the packages at the file we need. We said we are using the whitelist paymaster, and we will also need this. We will see the relay hub itself. So we added these two contracts just to make sure we have them in our source tree. Now I can, if I compile, it will reference them, and we will have the artifacts in our folder. Okay, so we added them. First of all, we need to deploy the whitelist paymaster. So first of all, we'll import it into our project. And we will deploy it. It doesn't take parameters, but we will need to provide him with several parameters. We have the paymaster. We need to set the forwarder in the paymaster. and we need to set the relay hub. So we'll get its address. And we will set it in the paymaster. And lastly, in order to make a request, the paymaster needs some deposit because it is going to pay for the transaction, so it needs some ETH. So let's deposit some ETH for it. We do that through the relay hub. So we need to get the relay hub first. Okay, we have the relay hub. We can deposit for, and we need the paymaster address. Let's put 1 ETH. Okay, so now the paymaster is configured. Actually, even the accept everything paymaster we've used before passed all these settings, but it is done with the GSN start. Here we are using our custom paymaster. But one thing I forgot, we need to tell this paymaster what is a whitelisted address. So if we look at the paymaster, it has a method whitelist sender. We need to call whitelist sender. And we need the address of our contract, the address of our account, sorry. So let's copy our account address. We want to whitelist that. We call this is a whitelisted sender. We will see shortly how we check this is the sender we allow. So we created now a paymaster. Now we need to use it. We will load its address. It will be deployed by the migration of Truffle, so we use it from the contract, whitelist paymaster. This is the artifact. And we use that instead of the accept everything paymaster. Okay, so the application will use this new paymaster. Let's start our application. Compile the contracts, you deploy them, they capture the flag, the new whitelist paymaster, and now it compiles the application that will use this whitelist paymaster. This is our application. Let's try to capture the flag. We can see we can capture the flag with GSN just the same. It will succeed, it mined, we see we capture the flag, but let's see that the whitelist paymaster did its job. Let's switch an account. This is another account. And let's try to capture it again. I signed the request. As a client, I don't care. The request is signed, but the paymaster rejected it. You can see the whitelist paymaster said sender not whitelisted. Let's see where this request came from. Sorry, this error came from. If we open the whitelist paymaster account, every paymaster has a method called pre-related call. It received the entire GSN request, and our paymaster failed on this request. It has a whitelist. It checks that the request from appears in the list, and it reverts if it doesn't. You can do whatever check you like in your paymaster to verify that the request is valid. This sample paymaster show how we check the from and the to, but you can do other things as well, like checking the request itself, checking the parameters, but we'll not go through it in this sample. Okay, so this is our tutorial for integrating GSN into your application. Thank you very much.